Okay, so the first thing I need for you guys to do, if you have experiment 10, or if you look at the circuit on the board, I don't know if you can see it with the lights on it, but I need you to go to your bag of parts and all mount those resistors to see if you have all the resistors I have listed on the board. So I'm going to give you, I'm doing that right now. I'm going through my resistors just to check. So far, I have everything except for the 5.6K. But you guys go through your parts. You may have them already sorted. If you do, that's great. See which ones of the resistors you have that's listed in experiment 10. I'll come back in about 5 minutes and we'll check to see. We got to make sure we all use the same resistors, even if we change some of the values. So see what you got. I'll come back in 5 minutes. We'll compare and then we'll get started. Okay, let's go through these resistors. Is anyone missing the 2.2K? Is anyone missing the 4.7K? Okay. Anyone missing the 10K? Is anyone missing the 5.6? Okay, well, it looks, I'm assuming then that you guys have all the resistors. I don't have, or at least I haven't found the 5.6. So if
I
you
did.
have it, does
All I
everyone,
was the 5.8.
you have a 5.8?
Yes, I didn't have
Okay,
the 5.6.
yeah, that's fine. 5.8 is close enough. Anybody else missing the 5.6 or something close? Okay, well, I don't have a 5.6. I do have a 6K. I think that's close enough. So I'm going to use a 6K here in place of R3. Now, I'm going to turn off the lamp. Let me see if I can still hear you. I forget how to do this. Can you guys, you can still hear me, right?
Yes.
Okay, I can hear you too. All right, great. So the first thing to do in this lab, you need a blank sheet of paper. You need a pen or pencil. Actually, you need your coloring pencils, and you need a calculator. The first thing we want to do before we actually go into the lab, I want you to solve this circuit. I like to know the voltage drop across each resistor, the current through each resistor. Now you're going to turn that calculation in with your lab, so make sure you go ahead and do it. We'll do it together, but you go ahead and do it to see what you come up with. You can use these values here that we have on the board, because I think everybody has resistors that are pretty close to these. So on your paper, neatly solve the circuit. I'll give you a few minutes to do it, and we'll do it as a group, and then we'll get into the lab. Okay, guys, we're gonna go ahead and solve the problem. So this is a series parallel circuit. You want to use your coloring pens and pencils. The first thing you want to do is identify the nodes, and then we're going to combine any node resistors because they're in parallel. It's a single resistor. We're going to end up with a equivalent series circuit. We'll solve the series circuit, and then we'll work backwards to the original circuit. So I have two nodes here. I have this one. And one on the bottom. I'm going to call this node A, and this node B. Now, if you're using another resistor for this 5.6, if somebody doesn't have it, just whatever that is, you can go ahead and solve for that resistor if you didn't. Actually, in your lab, when you actually do the lab, just cross it out and write in the actual value you use. If you're using the 6K, I'm going to use a 6K here because I don't have a 5.6. But if you have 5.8, that's okay. That's pretty close to this. It's probably just off a little bit. Anyway, I'm going to solve this circuit, and I see that, remember I start from the part of the circuit further away from my voltage source. I see I have two parallel resistors, R2 and R3. So I'm going to redraw this circuit, get the equivalent series circuit. This resistor is R2, parallel R3. Anybody do the calculation of these two in parallel? Let me know what you got for an answer if you did that. 4.7 in parallel with 5.6 is what? Did you guys not get it, or am I not coming through? 4.7 in parallel to 5.6. You can use product over the sum. You can use reciprocal rule. 4.7 times 5.6.
I got 2.56K.
That's correct. But if you didn't know how to get that, you can use product over the sum. And you should get the answer. But I remember this from last semester. 2.56K is what you should get. And remember, resistors in parallel, the total resistance should be smaller than the smallest resistor, which is 4.7, so that kind of checks out. My voltage is 12. And I got to bring my node information over. Node A is at that corner. Node B is at that corner, so I'll transfer that over. And here is my equivalent series circuit. I'm going to solve the series circuit, so I need for somebody to add up 2.2, 2.56, and 10K. What is that? 14 point what? 15 point something?
I got 14.76K.
14.76K for RT. My total resistance. And so now I can solve this. I can find my current by taking my total voltage, dividing it by 14.76 K ohms. What is 12 divided by 14.76?
.813.
You said 0.813?
Yes. Also, you're going off from the camera just slightly, so we can only see the 0.08 or point.
Okay.
Sorry.
0.813, and that would be in milliamps. So my camera, that's actually good to know. So I need to.
So would you like us to put that in the correct standard so it would be in, I believe, microamps?
This is microamps?
No, wouldn't we put it 3 more decimal points back? Move the decimal points 3 to the right. So that way it's a whole number and not a decimal.
Okay, yeah. So you're saying it's 813 microamps?
Pardon?
Are you saying it's 813 microamps?
Yes.
Okay. Yeah, you can do that. The only reason I'm leaving this way is because my resistors are in K, and then when I multiply them, it's gonna make the math a little easier. But you are correct. You can do that if you wanted to. So let me do something here though. I want to know where my camera mark is. Okay, so now we know the current. So I'm going to show the current here. And again, I'm going to leave this in milliamps just for convenience. And then over here, that's my main line current. That's going to be my current at R1. And also my return current down here is going to be the same. So I actually know the current here too is 0.813 milliamps. So I have calculated my current in R1, and I've calculated my current in R4. Now I need to get my voltage drops. If I take 0.138 and multiply it by 2.2, tell me what you get when you do that.
1.79.
1.79 volts across R1. And so I'll show it in every diagram. My red marker is dying. Let me see if I have another red marker. There we go. What about oh, I can do that in my head. So this is 8.13 volts across R4. So all I have to do is find the voltage from node A to node B. So you can either multiply 0.18 by 2.5K, or you can add these two up and subtract from 12. Either way, give me the voltage from A to B. How much is that?
2.08, 2.1.
Okay. So I know this is 2.08 volts across both R2 and R3. And the only thing we have unsolved is I2 and I3, but we can easily get that because I know the voltage across both resistors. I know the value of both resistors, just Ohm's law. 2.08 divided by 4.7, how much is that?
0.44.
And then the same here, 2.08 divided by 5.6. How much is that? Oh yeah, guys, I forgot. Charles, we corrected a problem. Okay, I remember it was a transformer problem, guys. That we I believe it was in your class, the last transformer calculation we did. One of the multi-coil transformer calculations, we actually made a mistake. If you go back and watch the video, you guys, I'm sure you've done that homework, but I just wanted to point out, I did get contacted by Charles. She had recalculated it and found out that we made an error. So hopefully, I don't know if you caught that error or not. We did a calculation on the board with the multi-coil transformer, and one of our coil voltages or secondary voltages was off, which threw everything else off. So you might want to go back and check that. I forget the exact, probably the first problem that we did. We only did one, I believe that. But go back and check that. I'm sure you probably turned that sheet in by now, but I just want to make you aware. Somebody tell me what is 2.08 divided by 5.6? How much is it?
.37.
All right, so this circuit is now solved. So I'm assuming you guys are checking this, and if more than one person is doing the calculations, if your numbers are not in agreement with this, speak up now before we go on, because I don't want to do, they look pretty familiar. I don't know about the currents, but I remember these numbers from last semester, so I think this is right. Anybody disagree with anything we have on the board? Well, if you agree with it, now let's go to the lab document. If you have the lab document, go ahead and take it out. And I'm not going to read the summary of theory. I want you to read it. But if you turn to page 92, at the very top of page 92, I do want to read something there. So this is a lab on series, parallel circuits, or combination circuits. And the problem is determining which resistors are in series and which resistors are in parallel. And at the top of page 92, he has a test. At the very top, he says the answer to the two questions will help you identify a series or parallel connection. Number one, will the identical current go through both resistors? If the answer is yes, the components are in series. If the answer is no, the components are not in series. So you can see for resistor 1 and resistor 4, the identical current goes through both resistors. So they're in series with anything that comes after it. These two are in series with each other, and they're also in series with anything that comes after it. Well, what comes after it? Well, that's the next part. Question number 2, are both ends of one component connected directly to both ends of another component? If yes, the components are in parallel. You can see that's true for R2 and R3. Both the top ends of R2 and R3 are connected through that node A, and the bottom of R2 and R3 are connected to node B. So they're in parallel. So I asked before, R1 and R4 are in series, and R1 is in series with anything that comes after it. Well, what comes after it? R1 is in series with the parallel combination of R2 and R3, which is in series with R4. So if you understand what I just said, hopefully you can just look at the picture and tell what's in series with what and what's in parallel with what. But he does give that test, that question 1 and question 2 that I just read. Now, let's go to the lab. I'm looking at page 92. Go ahead, and if you haven't ohmed out your resistors, go ahead and fill out table 10-1. Get your resistor values, ohm them out, write the measured values in table 10-1. I'll give you about 2 minutes to do that, and then we'll proceed through the lab. So you're filling out table 10-1 now with the measured value of the resistors. Again, if you use a different value for R3, I'm going to use a 6K. Somebody has a 5.8K. If you use a different value, just cross it out in the table. Write down the color-coded value under the column listed value, and then write down the actual measure value that you measure with your ohm meter. So go ahead and do that. I'll give you a few minutes to do it, and then we'll proceed. Okay, so by now you should have ohmed out your resistors, written the measure values in table 10-1. So we'll now move to procedure 2 of the lab. Procedure 2, we've already done this procedure, but we'll go through it anyway. It says connect the circuit shown in figure 2 and answer the following questions. Are there any resistors for which identical currents will go through the resistors? Answer yes or no for each resistor. So on the lab document, below procedure 2A, R1 and R4, you can see that they have the same current going through them. So you can put a yes next to R1 and a yes next to R4. R2 and R3 have different currents going through them. They don't have the same current going through them. So you would answer no for those. So you have yes, no, no, yes for procedure 2, part A, and then answer for procedure 2, part B. Does any resistor have both ends tied directly to both ends of another resistor? Answer yes or no for each resistor. We already went through this. We see that R2 and R3 have the top ends tied together and the bottom ends tied together. So they would be in parallel. And R1 and R4, they don't have anything tied together in common. So for R1 would be a no, for R2 and R3 would be yes, and R4 would be a no, and then you would have completed procedure 2, except that they want you to build the circuit. So what I want you to do now, we've been practicing over the last 2 lab sessions how to do a circuit build and getting familiar with the breadboard. So I'm going to give you a chance. I'm going to pause. I want you to get your trainer, and I want you to build figure 10-2. And I'm going to build it in front of you, but I want you to get some experience and practice doing it first. So go ahead, and you haven't already built the circuit, go ahead and do the circuit build, and then I'll build it. I'll give you a little bit of time to do it, and I'll build it. Make sure you set your voltage to 10 volts. To 12 volts. And when you set it to 12 volts, you test your voltage, but you want to retest it when you hook it up to the circuit. Because sometimes depending on the circuit you have, you can adjust the voltage to a certain value. And then when you connect it up, depending on the circuit you have, the voltage can actually change. So you can set it to 12, connect it up, and then recheck it to see if you have to make any adjustments. So go ahead and do your circuit build. I'll give you a chance to do it, and then we'll come back. We'll build it together, and we'll compare our circuits, and then we will continue with the lab. Okay, I'm gonna go ahead and do my circuit build. So what I'm gonna have to do is move off the projector, which when I do that, you guys can still hear me, but I won't be able to talk to you. So if you have a question, you'll have to send me a message through Collaborate. Before I do that, does anybody have any questions before I switch over? Okay, I'm gonna switch over. If you have a question, please just send me a message through the Collaborate, and then I'll switch back over and we can talk. So I'm going to switch over now to the .cam. All right. Let me just see. I don't know. Sometimes I believe it works better with the lights off. Let me look. I think that's a little better. All right. So we have a 2.2 to connect up, and it goes to the power. So remember, my power here, I have, well, you can't really see it. So my output, I still have the same wire from the last lab. So this is my positive V out. So I'll use that for my positive polarity. And then on the bottom here, I'll use this ground. So I have that already connected. And so what I'm going to do is I'm going to use this top rail here for my positive. I'm just going to plug it into here. So that makes this whole rail positive. And on the bottom, this green wire, we'll plug in that negative rail. So that makes this whole thing negative. Now, before I do that, I really should test my voltage. So I'm going to take these back out. I have yet to plug my trainer in, so let me plug it in. And it says we need 12 volts, so let me get my meter. I got this meter set up as a voltmeter, and I'm going to turn it on. You got to make sure you're on DC volts. Right now, I don't know if you can see it because it's out of focus, but I'm actually reading 12 already. So we must have set this voltage before. So I'm pretty close to 12. So then what I'm going to do is hook this up, and then I'll retest my voltage. So I'm going to hook this up. The rails, like I mentioned before, positive on the top, and then my negative on the bottom. So now I have both voltages. You want to make sure when you plug these wires in, sometimes if you have an older trainer, you should feel a little bit of resistance. If it goes in there real easy, you're not making a good connection. So you want to feel, you sticking it like this one, no resistance at all. I move over a little bit, and I feel a little resistance. You can actually look at, you can see, if you look in there, you can see the reflection of the spring that's in there. There's two springs that clamp together like that, and you stick the resistor in between them so that the resistor lead is like that. And they become weak after a while. Usually the first few holes, people use those to jump to the supply voltage. So sometimes you'll find that those springs are weak. Let's move it over a little bit and find one where there should be a little bit of resistance when you stick the wire lead into the hole. So I have this set up. I have my voltage set up. So now I want to connect my resistors. The first resistor is a 2.2K. So I'll get my 2.2K. It connects directly to power. So power, remember, is here. My positive polarity is here. So I'm going to just move it like this. Now I like to connect it up so that it kind of looks like the actual circuit diagram. You don't have to, but I do that because it's easier to troubleshoot. So I don't know if you can see it, but I have my 2.2 connected to this wire through the board, and it comes over to here. And so now I need to connect that. If you look at the schematic, that connects to R2 and R3, which are in parallel. So R2 is a 4.7K. So I'll get my 4.7K. And I'll connect here. Remember, this bridge right here is no connection. In other words, this common connection stops right here, and there's a new one on this side. So I'm allowed to go over to that other side like this. Okay, so I have these connected directly together. It's a little hard to see now. I don't know why I got out of focus all of a sudden. Let me see if I can bring it into focus a little bit. Maybe you can see that a little bit better. So I've just connected up R2, and now I want to connect R3 in parallel with R2. So R3 is my 5.6K. I don't have a 5.6, so I'm going to use a 6K. What I'm going to do is I'm going to put it right on the side over here. Like that. But they're not connected. They only connect this way. All right, so these two are connected because they're in the same column, but these two are not because they're in different columns. So what I got to do is get a jumper wire and connect the top of this resistor to that connection over here and the bottom to that connection. Now, if you know what you're doing with the board, you can actually use this rail up here to do that, but I don't want to do that. I don't want to confuse anybody. So you need two jumper wires. I got one jumper wire right here, so I'm going to connect the top of R2 to the top of R3. So now they're connected together. And I got to do the same thing down here. Now I'm going to move this up one because I got to make another connection. Okay, so hopefully you can see how this is coming together. I'll connect these two here with another jumper wire. So I'll get another jumper wire, and I'll connect the bottom of R2 to the bottom of R3. And now these two resistors are in parallel because I have the tops connected to the green wire and the bottom connected to the white wire. It's a little hard to see down there, but they're actually connected together. Sometimes what a student will do is they'll, instead of putting this in the same column, they'll have it to the left or to the right of the column, and you think you're connected and you're not. So if you have issues, you want to troubleshoot stuff like that. So I've almost got this done. The only thing I have yet to do is put my 10K in there, and I want the circuit to look like it does on the schematic. Again, you don't have to, but it just makes it easier to troubleshoot. So I have my R1 this way, so I'm going to have my 10K going back the other way, connected to the negative lead. So my 10K resistor is right here. I'm going to connect it to the bottom of R2. So it's connected to the bottom of R2. And the other side goes down to my negative lead, which is that rail at the bottom. I'm going to move it down here. And there is my circuit. So look at that. I don't know if how well that's picking up in the camera, but I like to play around with these lights. I don't know if it makes it better or worse. That makes it worse. That may be a little better, I don't know, but you can see it. I'll leave it there for a second. There is my circuit build. So make sure yours matches up to this. Some, you know, kind of not exactly like it, but needs to be close. And what I'm going to do is just one more time, I'm going to test my voltage just to make sure that when I hooked it up, nothing changed. I'll go from here to here. And I'll check my meter, and it still reads the same thing. You probably can't see it, but it's 12 volts, still the same. So I'm okay there. Now, before I go on, does anybody have any questions or any problem with this circuit build? Just send me a message if you do before I proceed, and I will go back to my voice communication thing. And if not, we'll just keep going. Okay, well, we will keep going. All right, so we have just finished procedure 2. So now I'm going to go to page 93, procedure 3. Procedure 3. Procedure 3 says, the answers to these questions should clarify in your mind which resistors are in series and which resistors are in parallel. Now, the questions they're referring to are the ones we just answered, the yes-no questions. It says you can begin solving for currents and voltages in the circuit by replacing resistors that are either in series or parallel with an equivalent resistor. In this case, begin by replacing R2 and R3 with an equivalent resistor labeled R2, R3, and draw the equivalent circuit in the space provided. Well, that's what we did. That was the stuff that we did at the beginning of class when I asked you to solve the circuit. So we've done all of that. We've done it. So what you got to do is you got to fill in the values, and fortunately, we've already done the calculated values. So if you're looking at page 93, get your notes, the calculation you just did for the circuit, and go ahead and fill in the computed values on page 93, table 10-2. You have the value for V1. You have the value for no voltage, node A and B. Well, that would be your V2, V3 voltage. And you have the value for V4. Go ahead and write those in. We just did those calculations. And in the lab, what you always want to do, you always want to calculate your values first. I have some students that will come in or try to come in and measure everything and then go home and calculate it. Well, if you do it that way, how do you know what you're measuring is correct? So you always measure, you always calculate first, do your theoretical values first, and then measure to see if your measured values are close to the theoretical values. So you always want to do calculated values first. So we've done that. We got the value for V1. We got the value for the no voltage AB, which they call V2, 3. And we got the value for V4. So what they want you to do in this table is they want you to measure those values. You're going to measure RT. We said RT was, what was it? 14.76. You're going to measure. Now, when you measure RT, you got to disconnect it from power. They want you to measure RT. They want you to measure V1. They want you to measure V23 and V4. And you don't have to do this right now. You can do it later on. But at some point, you want to go and you want to calculate those values using Ohm's law. And so that only refers to V1, V2, and V4. They want you to calculate the voltages using the voltage divider rule They want you to calculate it using Ohm's law. We already computed it using Ohm's law. So when you write those in, you should write it under the Ohm's law column. I should have told you that. So the one you'll compute, you'll write in what we did on the board, the calculation we did on the board goes in the Ohm's law column. We use Ohm's law to solve for those voltages. We use I times R. But they want you to do the voltage divider rule. So I'll let you figure that out, how to do that. You don't have to do it now. You do it after we're done with our session. But go back and you can calculate. So right now, all you got to do is write in your voltage values for V1, V2, 3, and V4, and then measure them to see how close they are to what we calculated, and then measure your total resistance. So I'm going to give you some time to do that, and then I'll come back and we'll kind of do it together to see how they compare. So go ahead and complete table 10-2, everything except for the voltage divider rule. If you have time, you can do that too. But get your measured values and let's compare them to what we calculated. So we'll see what you got. Okay, I'm going to go ahead and make some measurements now. So I'll need my voltmeter. I'm going to move these over just so I have a little bit more room. All right, so For V1, we got 1.79 volts. So let's see what we get when we go across here. I don't know if you can see that, but that's 1.77 volts, so that's pretty close. For V2, V3, this is node A, node B. They call that V23. We calculated 2.08 volts. So we'll measure across the two parallel resistors. Now, since they're in parallel, you can measure across either resistor, it doesn't matter. So I want to go across this one, it's a little easier to grab. And put my other lead over here. We got 2.13, we calculated 2.08, so that's pretty close. And then the last one should be 8.13. So let's see what we get for the last one. We got 8.09. So those values are very, very, very good, very close. Even though I used a 6K resistor, I use a 6K resistor. So if I had not used that 6K resistor, it would be even better. Well, the last thing they want us to do is measure the total resistance. Well, anytime you measure total resistance, you must disconnect your power supply. Watch what happens if I try to measure with my power supply hooked up. So I'm going to move my meter to ohms. And I'm going to try to measure it with power hooked up. So I'm going to put it here and here. I'm not getting anything. I'll disconnect my power though, which is what you want to do. So I'll disconnect power. You only need to disconnect one. But now I got a reading. If you can see, I got 14.96, and we calculated 14.76. So we're in the ballpark here. And again, remember, I used a 6K resistor instead of the 5.6K. So I think we're, with this lab, our measured values are excellent if you got numbers close to these. Okay, so I'm going to switch back over to where you guys can talk to me. So I'll go here, and then I'll mute it. Well, actually, I don't have to mute it. So does anybody have any questions over that first circuit build? Did everybody get values? Did you see how to connect up your circuit? Okay, well, we're going to proceed with the lab now. We've got one more part to do. And look at the lab and look at page 93. We're going to move down to procedure 4. Now, in procedure 3, let me finish reading procedure 3. It says the answer to these questions can clarify in your mind which resistors are in series and which are in parallel. You can begin solving for currents and voltages by replacing resistors with either series or parallel with the equivalent resistor in this case. So in that space there, they want you to draw the equivalent circuit. Well, you don't have to do that because you're going to submit your actual calculation when you submit the lab. So with that space they left there between procedure 3 and 4 was for you to draw the equivalent circuit. But since we already done the math, you don't have to do that. So now moving to procedure 4. The equivalent circuit you drew in step 3 is a simple series circuit. Compute the total resistance of the circuit and enter the first. Okay, we've done that. We move into procedure 5. Procedure 5 talks about using the voltage divider rule. Now I'm going to let you figure out how to do that. I'm not going to do it for you. Go back and look at the video on voltage divider rule. You can apply the voltage divider rule to the equivalent circuit, not to the series parallel circuit, but to the equivalent circuit. So when you read procedure 5, keep that in mind when you go back and do your calculations. And then they're going to have you find the total current and so forth. So I want to move to the part of the lab where they have us, they're going to have us redo the circuit. So procedure I'm going to procedure 10. So jump to procedure 10, which is on page 94. So look at page 94. Procedure 10, what they want you to do is they want you to change the original circuit. You got the same values, but they want you to change it to what you see there, figure 10-3. And all you got to do here is make some more measurements. Now, you don't have to measure current. They want you to compute the current. So I'll let you compute the current, but you should be able to make the measurements. So what you want to do is reconfigure your circuit to look like figure 10-3, and then do your measurements to see if your values are what you compute. Now, I'm not going to compute it. You guys go ahead and do that. You should solve the circuit, and you should compute it. We did one. You know how to solve a series parallel circuit. I would solve for the current and voltage through and across each resistor. Write those computed values in table 10-3 so you know if you're doing it correctly. And then go ahead and do that circuit build, and then test to see if your measured values are actually close to your calculated values. Now, I'm not going to calculate them. I'm going to leave that up to you. I will do the circuit build, and then I'm going to end the video. And what I hope is that we got like one more lab to do, but you guys, eventually you should catch on to how the board works and be able to do your own circuit build without me guiding you through it. So go ahead and do it. Do your computations, and then do the circuit build. And then I'll do the circuit build, and then I'll let you guys make your own measurements. Okay, so go ahead and do it. I'm going to give you some time to do it. Okay, guys, I want to go ahead and do the build of this circuit, and then we'll wrap it up, and you guys can do your own measurements and calculations. Before I switch off this machine, though, does anybody have any questions before I switch over? Okay, well, I'm gonna switch over to the project the circuit, and then I'll come back and we'll wrap it up. So you will now not be able to talk to me, and I'll get my schematic. And what they've done on the schematic is they rearranged this so that R1 and R2 now are in series, and R3 and R4 are in series, and then those two series branches are in parallel with each other. So I'm gonna build this a little differently. I know I said I'm going to build it like it is on the paper, but all I'm gonna do is I'm gonna move R3 right above R4, so it looks like kind of 4 resistors in parallel. That just makes a little bit more sense to me. Okay, so they all have the same values as before. R1 is still 2.2, R2 is still 4.7. They just rearranged them. So let's go ahead and let's do this circuit build. So I'm going to remove these wires, turn this off for a second, and remove my meter leads just so we can see. So I have R1 and R2, and I want to put those in series. So here's R1 and R2. I want to put those in series. So I want to just do that. They kind of already are in series. I'm going to use this rail down here, though, as a wire. So I'm just going to connect a resistor there. This is R2. And I want to connect it to R1. So now what I'm doing is I'm using these rails. So I got the resistor plugged here. I jump it across that little canal because it's not a common connection across it with the resistor, and then I got to connect it in the same row with R1, and then the top of R1 connected to power through that rail. So I'm going to repeat that with the other 2 resistors. So I have 4 resistors kind of like right next to each other. So I'll take this resistor, put it like this. Bring it up. And again, I'm going to use the rail as a wire, so I can just go here and then into that top rail. And now, instead of having that top resistor going sideways, it looks better to me to just have them. And now I can see I have 2 parallel branches. Now, so now you should be able to hook up your voltage and make your measurements. Now, there's one thing I will show you to give you a hint, because students usually make a mistake here. If you look at the lab, notice they want you to measure the ohmic value of resistor 1 and resistor 2. So let me show you the way a lot of students will do it. They know that you can't connect up read the ohmic value with the power connected, so they'll disconnect the power. So they'll say, all right, I'm going to take the power off this. So I'll disconnect the power. Power is disconnected. And then they want to measure. It says measure between resistors R1 and R2. Now, if you look at that, look at the schematic diagram. R1 is about 2.2 or 2.3, and R3 is about close to 5. So I should have, what, 5, 6, 7? I'm kind of about something close to 8K or around that value. So they'll say, all right, well, let me get my ohm meter. and I'll measure it. They take their own meter, and they can put one lead here, and one lead here. And I don't know if you can see the meter, but I should be reading something closer to 8K, and I'm only reading 4.86K. Now, does anybody know what I did wrong? And I know you can't talk to me, right? Oh, yes, you can. No, I guess you can't talk to me. What did I do wrong? What's wrong with that connection? Anybody know?
Is it because you still have the power connected?
I disconnected power. I showed you I disconnected power. So that would be the first thing to check, though. Usually when that mistake is made, you do forget to disconnect power. But I made that check. I disconnected power. I'm still getting the wrong reading. So let me go back to the circuit, let you look at it again. And I'm going to come back to you. So look at the circuit. It should be reading something close to 8. It's reading 4.85K. So I ask you again, does anybody see anything wrong with what I'm doing? There's nothing wrong with my circuit. It's what I'm doing. What am I doing wrong?
Is it the points that you're measuring from?
Kinda. I don't know. Can you say a little bit more about that, or are you?
I don't know, it's hard. It's just kind of hard to see like the actual trainer.
Okay. Let me go back and let's talk about this. The reason why I'm measuring the wrong value is putting the leads here. I want to measure across R1 and R2. So some students think I'm measuring by putting the lead here and here, and I'm measuring across those two resistors. I'm actually measuring the resistance of the whole circuit. Do you see why? Because they're still connected through the board. So the only way to measure, if I only want these two resistors, I got to disconnect this side over here. I got to pull one in and out. Because right now, you're thinking, well, I'm from here to here, I'm measuring those two resistors. No, you're not. You're measuring the whole circuit because they're still connected here and here in the board. So watch what happens when I pull. What I'm going to do is pull this in and out, and watch what happens to my meter when I do that. So I'll come over, I'll pull this out, and my value changes to 6.96K, which is closer to the value that I expect to read. So if I want to measure just these two resistors, I got to open this up, disconnect it from the circuit. Now I'm just getting those two, and then I'll do the same thing. Now the other two, we'll do it again. Let's repeat that same mistake. We're going to connect these back up. Now, let's see, I got a 10K and a 5.6K. So I should have over 15K ohms when I go across these two resistors. If I come over here, you're going to find that I have exactly the same value I had before, the 4.86 or whatever it is. Because I'm not putting the lead here and here, I'm not measuring those two resistors. I'm still measuring the whole circuit. I got to pull one of these out, and then you'll see this go closer to something that we expect, the 15K. So I'm going to disconnect one end of that, and I'm on the high side because remember I'm using a 6K instead of a 5.6, but it goes to the value that you expect. So don't make that mistake when you're measuring resistance. Putting the leads across the 2 points where you want does not guarantee you're measuring only those two resistors. You got to make sure that's the only thing in the circuit. Okay, so I'm going to let you look at this one more time, and then I'm going to let you finish the lab on your own. That's really all I have. There is the completed circuit, and you still have to go in, and hopefully you did your computer values. You got to measure. You don't have to measure current. I have that X'd out, but all your resistor measurements and your voltage measurements, you got to do those. But those hopefully are pretty easy to do. So now switching back to where you guys can talk to me. does anybody have any questions or comments before we end the session today? Okay, well, the lab is complete. We have one more lab to do, and I need to look at your work. I know you got some stuff, some links I got to give you. Maybe fit one more quiz in. I don't know what was the last thing we quizzed over. I know you texted me some stuff. So we have one more official day of class. The semester doesn't end until the 8th, and I think the 8th is on a Saturday. Let me see. Yep. So I'm I'll look, and over the next day we got one more lab and possibility we can do another graded assignment, some kind of quiz or homework or see. I'll see where we are grade wise. Guys, have a great rest of the evening. I'll see you at the same time on Thursday. We'll do our final lab for the semester, and then that'll be it as far as the video lectures and labs go. Have a great rest of the day, and I'll talk to you guys later.
I had a question about Lab 4.
Okay.
I had emailed you about it. I went to turn it in Friday morning, and the link was gone. So then I emailed it to you, but I'm not sure what I should do about it.
You emailed it to which email account?
I emailed you on the Surge email, just your name.
Oh, okay.
And you had emailed me back earlier today and asked if I had tried to submit it after it was due, but I went to submit it before it was due, and it was gone. So I'm not sure where to submit it at or not.
That's kind of odd because no one else said that. But you can you emailed it to me, right? So if you emailed it to me, it should be all right. I should have it.
Okay.
But yeah, I'll you may want to send me another text, not tonight, maybe tomorrow or something. But if you emailed it to me, I'll have it. Let me go in. Hold on a second. Let me see if I can go in. Let me see if I can do this. If I go in and I might be able to reset that link for you. Give me 1 second. I want to go to course documents. I want to go. Wait a minute. I'm in the wrong course. That's not the right course. Let me go to another fundamentals, course documents, labs. Yeah, so lab 4, it should have disappeared on July 30th. So it was, it says last available on July 30th, but I'll go in and reset that.
And the email that you had sent about that lab, it said it was going to be due the 30th was Thursday night. But in the email, you said it was due Friday night before midnight. So that's why when I woke up Friday morning, I went to turn it in. And
that's why I was gone.
So it must have disappeared Thursday night. But
yeah,
I was just going off the email.
Okay. I think there's a place for you to look when you download though. I don't know what you guys see. I guess. Well, hold on. Let me reset it and hold on a second. Let's check something. So I want to reset this. I'll give you. I'll make it do. What's today? Today is the 4th.
Yes.
I'll make it do. I'll do it Friday and submit it. Let me see. So this is what I see as an instructor, but I think I can go here and change it to a student view.
Yeah, the Lab 4 link just showed up.
Okay, so yeah, I wondered if it said, so you guys can't see when it's due other than it said posted. That's odd. So it's only what I have here. Okay. All right. Well, you should be able to submit it now.
Yeah, I just submitted it.
All right. Is that it?
Yeah, that should be it.
All right. Then you have a great night. I will see you later.
All right. Thanks.
Bye-bye.